Here we'll be looking at the area of parallelograms and triangles. To begin, let's look at a brief warm-up and try to find the area of the purple shaded region here. So pause the video and try to do that to see if you can remember certain geometric formulas. All right, let's see how you did. So if you notice the triangle, it's a 45, 45, 90 triangle. To go from your 90 side to your 45 side, you divide by root 2. Of course, you rationalize the top and bottom, so you get 12 root 2 over 2, which is the same thing as 6 root 2. So that gives me this side of the rectangle. Now that's going to be 30 because these have to have to 90, so you know your 30 side. To find your 60 side, you multiply by root 3, so it gives you 6 root 6. Now if you remember, the area of a rectangle is length times width. So 6 root 6 times 6 root 2 gives you 6 times 6, which is 36. 6 times 2 is 12. Break it down, 4 times 3, pull out a 2, so 72 root 3 inches squared is your area of the rectangle. Now it's important that you remember that when you find area, your unit has to have a square on it because area is two-dimensional. That's why we put the 2. All right, so let's go ahead and go through area and perimeter parallelograms and triangles. So the area of a parallelogram is, well, here's a parallelogram diagram right here. You can see the base here and the height here. If I take this triangular part and drag it, what shape do you notice is formed here? Well, it looks like a rectangle, and we know to find the area of a rectangle, it would be base times height. So, to find the area of a parallelogram, it's the same formula. The area equals the base of the parallelogram times the height of the parallelogram. The base is one of the parallel sides. The height is the perpendicular distance between the bases. Notice it can go this way as well because this is the perpendicular distance between the bases. Also, I could draw a height here. That's the perpendicular distance between this base and this base. I could even come out here and draw a height because that's still the perpendicular distance between the bases. All right, so pause the video, see if you can find the area and perimeter of the parallelogram. All right, Pythagorean theorem tells me this is 5. So the perimeter is going to be 8 plus 5 plus 5 plus 8 is 26 centimeters. Now it's just going to be centimeters because it's one-dimensional. The area is going to be 8 times 4 because that's the base and that's the height. So 32 centimeters squared. Once again, on each of these problems, I would pause it before to see how you do. Now we need to find the height of this parallelogram. It gives me an angle and a side, so I'm going to have to use SOHCAHTOA, trigonometry, to find the opposite side. So in terms of 35, this is the opposite side, and this is the hypotenuse right here. So what involves opposite and hypotenuse? Sine. So sine 35 equals the opposite side, which we'll call x, over 5. Cross multiply. 5 sine 35 equals x. So now all you got to do is type in 5 sine 35 into your calculator, and you get the x equals 2.868. So you do the base, which is 10, times the height, gives you 28.68 centimeters squared. Don't forget, for area, you need the square unit. Okay? So here we have another parallelogram. We have 30, and this is my 90 side. So to go from your 90 side to your 30 side, you divide by 2. So the height is just going to be 2. So the area is 20, and the perimeter is 28. Now you might sit here and say, wait, the perimeter is bigger than the area? No, it's not that it's bigger. These are different measurements. A square unit is different than just a length along a side. All right, now let's look at the area of a triangle. The area of a triangle is base times height divided by 2. So it's different than a parallelogram because we have to divide this by 2. The height is still the perpendicular distance from a vertex to the base. All right, so let's find the area and perimeter of the triangle. So pause the video, see what you can do with it. All right, so using the Pythagorean theorem, we know that this side is 6 because 6x squared plus 8 squared equals 10 squared. It's got to be 6. It's a 3, 4, 5 triangle. So the perimeter is simply 24 meters. Now, to find the area, the base is 8 times the height, which is the perpendicular distance. Oh, look, a 90-degree angle. So 8 times 6 divided by 2 gives me 24 meters squared. These numbers are different because this is meters, this is meters squared, so square meters. So don't think that these are the same measurements. All right, pause the video and see if you can use trig to find your missing height. All right, reference angle is 25. This is the opposite side of this hypotenuse. So once again, I'm using sine of 25 equals x over 7. So 7 sine 25 equals x. Multiply it through. You get that the height is 2.958. So you do the base, which is 12, times 2.958 divided by 2. 12 times 2.958 divided by 2 gives me the area is 17.748 inches squared. Hopefully you got that one with trig. Now let's find the area of this triangle. It is an equilateral triangle, so we're going to drop the height. And we know that this will be a 60-degree angle because if it's equilateral, it's equiangular. Cut this in half so it's 3. So I know my 30 side. I want my 60 side, so 3 root 3. So base times height, so 6 times height divided by 2 gives me 18 root 3 over 2, which is 9 root 3. Now, I'm going to show you a formula that works for equilateral triangles for the area. So the area of an equilateral triangle, this only works for equilateral triangles, can also be represented by s squared root 3 over 4. Now that might seem more complicated, but watch how easy it is once we apply it. We don't have to do any of this extra work. So the side is 6 for the equilateral triangle. So 6 squared is 36 root 3 over 4. 4 goes into 36, 9 times. So 9 root 3 feet squared. So either way, we get the same answer. But with this formula for an equilateral triangle, it's a little bit easier to get there. All right, last two questions. Anne sketched these figures in her notebook during a geometry lesson. If a fly lands at random on the grid, is it more likely to land inside a shape or on the blank grid? Well, let's find the area of both to figure it out. So the area of the blank grid is going to be 20 times 6 because it's a rectangle, which is 120 units squared. Here, this parallelogram has a base of 4 and a height of 3. So 4 times 3 equals 12 units squared. The rectangle has a height of 4 and a base of 3, so that's also going to be 12 units squared. The triangle is 1, 2, 3, 4, 5, 6, 7, 8. Then it's 1, 2, 3 is the height. So 8 times 3 is 24. Divided by 12, 2 is also 12. So all three of these shapes have the same area. So the probability that it'll land on the parallelogram, well, it's 12 over the total, which is 120, equals 1 over 10, which is the same thing as 10%. The rectangle will be the same thing, so 10%, and the triangle will be the same thing as well. So the probability it lands on one of these three shapes is 30%. So the probability it lands on the shape is 30%. What's the probability that it won't land on one of those shapes, but on just the grid? Well, 100 minus 30 is 70%. So it's more likely to land on the blank grid than it is to land on the shape. All right, finally, here we have a composite figure. We're going to draw the altitude here to make a triangle and a rectangle. 120 times 60 is 7,200 meters squared for this rectangle. Now here, if this is 60, this piece is 140. If this is all 120, this is 40, it leaves 80 here. So I'm going to do 80 times 140, divide that by 2, and you get 5,600 for this piece. So the total area is 12,800 meters squared. Here's the homework assignment for K. Make sure you do it tonight. Thank you for watching. Good luck.